So we can write it this way. And the gamma of k is the visible set, meaning that your CT is actually constrained by the state you have at this period kt here. Okay? And of course, with a little bit, you change a little bit notations, then you can write it this way. So once you decide the CT here, you will automatically get the capital stock for the next period. So that's why we can directly put it this way. And what you need to decide is actually CT over there. Okay. So there are like two further observations from this case. Kind of try to simplify the problem. Okay. So if you write it down this way, then the choice variable is actually CT here. Okay, and you can rewrite it into a function, like writing down, how to say that, by using the capital stock. So the equations above is like we substitute the kt plus 1 as a function of ct, but we can actually replace ct as a function of k as well, which is look like this one, and we keep the kt plus 1 there. Okay, and if you write it down this way, then all of them are a function of k, and also the plum. So this is a conventional way to use the notation. So if the state or the variable is at the current period, then we don't put anything on it. We just put it, for example, like k here. That means that is the variable for current state t. And if we put a plum here, which is k plum, that means that is the variable at the next period, which is kt plus 1. Okay, so we can rewrite it this way, which is more concise. Okay. Okay, then what's next? These two terms is kind of annoying, right? Because now we still have t here, t plus 1 there. Then you think of the following situation. Says that you face two problems right now. The first problem is that, okay, I tell you that now you have the capital K at the period t, okay? And you assume that you already solve the value function. So that will directly give you a numbers over there. Okay, so you already find the optimal path. Okay. Then the second problem is that, again, I tell you that now you have the capital K again, but at period t plus 1. And I will ask you to solve the value functions again. And you will tell me that, okay, so the optimal consumption path is actually the same. What's different is like the consumption starts from period t to infinity, or it started from t plus 1 to infinity. What happens before doesn't matter, because I already tell you that at period t you have capital K, then you tell me the optimal consumption path. And says that now I change the time period. Now you are at period t plus 1, and I still give you the same amount of capital. Then your consumption path is still the same. Okay? What is different is that we want to have the same standard to compare. So the simplest way to think about it is that $100 today is different from $100 in like a year later, right? So between these two, we need to have discount, and that's why we can write it this way. So this is the discount factors Okay, and once we put it this way, then we can actually write in a very concise form, which is Bellman equations you will have, and you are going to see it a lot of times in a graduate course in the economic field. Okay, so that is the Bellman equations, which is going to help us to solve the infinite period problem. Okay, and once again, this remark. So we will have like the variable at period t, which is didn't put anything, t plus 1 put a plum over there, and x2 t double plum. But just be careful when you use it. Okay. Okay, so we are going to have like 15-minute break, and see you back in 32. Yeah.